advent of the automobile, it became necessary to enact legislation to ensure safe use of the public highways. To minimize an alarming toll of death, injury, and property damage, safety regulations had to be imposed upon all traffic using such highways. Various devices are used to control vehicular traffic. Signs along streets and highways serve as guides or warnings to the motorist. Wide and direct highways have also been designed to lessen the hazards of travel and facilitate safe cross-country transportation by land. Similarly, sky highways have been established for aircraft. Known as civil airways, all their traffic is governed by regulations which are issued by the Civil Aeronautics Administration, a division of the Department of Commerce. These rules for flying are further amplified by the War Department for all Army flights. Military pilots, therefore, must also observe these regulations and all current amendments affecting established rules of the air. Civil airways may be defined as imaginary air roads 20 miles in width connecting a series of airports. But these airways, unlike the land highways, have no limitations regarding the levels of travel. Through airway traffic control centers, located at principal cities throughout the United States, air traffic is regulated in much the same manner as a railroad operates its trains. Such a center receives advance notice of aircraft traveling within its area and maintains constant contact with such aircraft. Each message received is forwarded from the communication station to the control room, where the route of flight is checked. An airways map serves as a basis for plotting the line of flight through this control area, computing mileages, radio fixes, and determining other information necessary for making estimates before the issuance of control instructions. A flight progress strip is now posted at each radio fix or station over which the pilot will report his time of passing and altitude. Each strip will contain the flight identification number, the aircraft call number, the type of aircraft, the cruising altitude, the estimated time the airplane will cross the radio fix. One strip is prepared for each radio fix to be crossed and one for the point of destination. As the pilot flies over each radio fix, the time and his altitude are recorded on the progress slip. At an airway traffic control center, contact is maintained between stations within that area by interphone, supplemented by the teletype communication system. The interphone circuit and the teletype circuit provide a constant source of information as to weather and flight for relay between aircraft and the airway traffic control center. The grid shown here indicate control areas of traffic control centers. Flight from one area to another must be approved by each area concerned. This second chart shows additional control areas to be added shortly. A traffic control center does not communicate directly with pilots. The pilot contacts the nearest ground radio facility, which in turn transmits the message to the traffic control center. The information is returned through the same channels. Many such facilities are available, including the Air Transport Company radio, airport radio, radio range station, or a military radio. Dictaphone permanent recorders in each traffic control center make a record of all messages sent or received on the interphone circuits within the area. This enables a check on the accuracy of information transmitted or received. Each sleeve makes a record of 45 minutes of conversation. The Chief Airways Traffic Controller at the control center makes all decisions regarding any irregularities in flight plans, messages, or flying routines. Airways, like highways, form a network presenting a fusion of lines which would permit aircraft to collide at intersections were it not for the establishment of priorities or rights of way. Connecting principal cities, the coast-to-coast airways traveling generally in an east-west direction are given a color designation. These are the green routes and have intersection priority over all others. Arterial airways designated for through traffic in a generally north-south direction are known as amber routes and have a second priority at intersections. Short connecting routes which join artery airways with intermediate points are the red airways. They travel generally east and west and have third priority. Those having the lowest priority are the blue airways. They are short connecting routes traveling generally in a north and south direction. Together, these four classifications of airways comprise the airways system of the United States, an airways system with which all pilots, including military flyers, must be familiar. G, A, R, B, GARB. Airways priorities are remembered in this order: green, amber, red, and blue. Another phase of flying is contact flight, which is dependent upon visual reference to the ground. The pilot must be familiar with airway beacons, those lighthouses of the skyways. He must also be able to recognize ground markers and lights at all airports and landing fields. Placed at strategic points of higher elevations are lofty steel towers. At the top of each is a revolving beacon light which marks a 10-mile interval along the airway. At night, it projects a strong beam of light visible in all directions and revolves on a horizontal plane. In connection with the revolving light is a green or red blinking light, visible principally along the path of the airway. Green flashes are used at intermediate landing fields, and red flashes are used at beacons where landing fields are not available. Each colored course light flashes in code the numerical designation of the beacon. This light is giving the signal dash, dot, 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 which corresponds to its code number on the map. On the ground at the base of some beacons is located a large directional arrow pointing to the next higher numbered light along the airway. The lights are numbered from west to east or south to north, depending upon the general direction of the airway. Some of these course beacons are identified by numbers and letters on the roof of the small powerhouse. The number identifies the beacon by day. The letters designate the airway. CP identifies the airway from Columbus to Philadelphia. The lettering on the side of the building denotes the ground elevation. Beacon lights at Army fields or stations, which formerly were split revolving beacons, are flashing radial beacons, visible in all directions. They consist of a Fresnel lens optic in which the lamp is moved periodically up and down. The result is a radial beam of light that sweeps through a vertical angle from 2 to 18 degrees above the horizontal. When viewed by a distant pilot, the beacon appears to flash 80 times a minute. Intermediate landing fields are maintained at various intervals along airways. They provide for emergency landings of aircraft. Ground markers and boundary lights show clearly the limitations of the field. These lights burn from 15 minutes before sunset until 15 minutes after sunrise. Whenever an Army flight is proposed, it becomes necessary for the pilot to secure certain information at the operations office upon which to base his flight plan. After consulting an airway map showing the area over which he is to fly, he must ascertain the distance. He makes use of a distance measuring chart, which is designed for immediate computation of air miles and is available at the operations office. By simple manipulation, he learns, for example, that the distance from Wright Field, Ohio, to Langley Field, Virginia, is 450 miles. The pilot now visits the weather office, where he examines reports from various points along his proposed flight route. If visibility and weather conditions are favorable, a contact flight may be made. The pilot completes a flight plan which contains the point of departure, address, date, the type of aircraft, its identification and home station, his name and names of other occupants, routing of the flight, destination, proposed cruising speed, time of takeoff, estimated time en route, including time necessary for any intermediate stops, radio transmitter frequency, and his signature. Army pilots find such flights quite easy once they are familiar with the procedure and the rules of the road. These rules closely resemble those of the highways in many respects. Approaching aircraft avoid collision by each giving way to the right. Likewise, a similar safety precaution demands steadfast flying on the right-hand side of the airway. When two aircraft are on crossing courses, the aircraft to the left gives way so that the one on the right may exercise his right of way at the crossing. Contrary to auto traffic, however, when one aircraft is overtaking another, the faster will pass to the right. Contact flying, which affords such valuable training to military pilots, is recognized by the CAA as a very important means of aerial navigation. For safety's sake, pilots are required to observe certain limitations. They may drop to as low an altitude as 500 feet while passing over open country. But to safeguard property and for the safety of civilians as well as the pilot, when passing over an industrial area, densely populated section or city, the pilot must maintain a minimum altitude of 1,000 feet above all obstacles. Moreover, the altitude must be sufficient for an emergency landing in a nearby field in the event of a power failure. One limitation imposed upon contact flight is the height of the ceiling. For example, the lowest ceiling for contact flying during the daytime is 1,000 feet. This means that the aircraft, while maintaining its 500-foot altitude, will still be 500 feet below the ceiling. During periods of precipitation or at night, the ceiling must likewise be 1,000 feet and the flight altitude remains at 500 feet. When making contact flights at 1,000 or more feet above the ground, a minimum visibility in a horizontal direction of at least 3 miles is considered essential for safety. Contact flying also requires a 3-mile visibility on the ground at all times while within a 3-mile radius of an airport control tower, such as those which control traffic at most of the larger airports. For flights beyond the 3-mile control zone, at altitudes of 1,000 feet or less, and during hours of daylight, a minimum visibility of 1 mile is necessary. At night, a 2-mile minimum visibility is required. When it is desired to increase or decrease altitude, and it is apparent that it will be necessary to fly through an opening in a horizontal layer of clouds, the pilot should select an opening which will permit a clearance of at least 2,000 feet on all sides of the aircraft. This clearance minimizes the danger of collision in the event another aircraft is attempting to use the same opening. But after such a change in altitude has been completed, it is important for the pilot to bear in mind at all times that the flight path must still be controlled by visual reference to terrain features. While contact flying requires training and practice, instrument flying is much more involved, as all Army pilots know. Like our military air forces, the CAA realizes how essential instrument flying is and has made rules which apply to military and civilian flyers alike. The Link Trainer, a useful device which is available at many training centers, teaches young pilots to depend solely upon their instruments while in flight. Fully equipped with airplane instruments and controls, this electrically operated device encloses the pilot and requires operation without reference to outside objects. Instrument flight navigation, because of clouds, smoke, haze, rain, snow, or other obstructions of vision, must follow the CAA rules. These rules require that the pilot gather more detailed information for his flight plan than was required for contact flight. A thorough knowledge of current weather conditions is very important for instrument flight. This information is entered on his flight plan. From the teletype printers, he can also get hourly weather and atmospheric reports along the proposed flight line. These reports are supplemented more frequently if atmospheric changes are anticipated. Standard abbreviations and symbols contribute to speedy transmission of the reports. From the reports, the pilot compiles such information as the specific altitude for the flight, proposed time of departure, and an estimated time en route. This information must be transmitted to and approved by the Airway Traffic Control Center concerned. The message is cleared immediately by the use of the teletype or interphone. The pilot must also name an alternate airport. This is an alternate landing point having a more favorable weather condition. In the event atmospheric conditions at the original destination become unflyable, he makes a landing at his alternate airport. The pilot must likewise keep the fuel capacity of his aircraft in mind. Although each plane is fueled to capacity before flight, regulations limit the flight distance so as to ensure arrival at the point of destination, thence to an alternate airport, and then sufficient fuel for 45 minutes of cruising. On land, MPs can give right-of-way to the Army. But in the control of air traffic, military aircraft are under the same airway traffic control centers as civilian aircraft. When more than one aircraft is scheduled to fly in the same direction and at the same altitude, the control center directs that the takeoffs be separated by a minimum of 15 minutes. This spacing of aircraft is a safety measure. The radio enables the pilot to request any necessary changes in his flight plan. Although approval is granted only by the Airway Traffic Control Center, the pilot sends his request to the nearest airport or radio facility. Aircraft operating under instrument flight rules will report by radio to each facility en route and maintain a constant listening watch on the voice channel. To ensure safety, all airways, according to their types, are assigned certain altitudes for instrument flight navigation. For example, all northbound amber or blue airways or eastbound red or green airways are restricted to odd 1,000-foot levels, such as 3,000, 5,000, 7,000, and so forth. Flight of aircraft in opposite directions on these airways is restricted to even 1,000-foot levels, such as 2,000, 4,000, 6,000, and so forth. Therefore, airplanes flying in opposite directions on a given airway are separated from one another by at least 1,000 feet in altitude. Since aircraft may fly on airways both south and west at the same even 1,000-foot altitude, or north and east at identical odd 1,000-foot altitudes, collision at intersections of such airways, not in a control area, is prevented largely by strict traffic regulation. This requires that aircraft on an airway of lower priority must increase its altitude 500 feet when crossing an airway of higher priority. Radio ranges located along airways contribute materially to instrument flight navigation. Each provides 4 directional beams for the guidance of aircraft traveling the airways. Communications failure due to excessive static or other reasons occasionally occurs while on an instrument flight. The pilot then may choose from 3 approved procedures. First, he may continue flight in accordance with contact flight rules, if this is possible. Second, he may effect a landing at the nearest suitable airport. Third, he may continue flight in accordance with his flight plan and his amended instructions if flying within a control area. Normally, an aircraft on instrument flight, with its radio in operation, will contact the airport of destination for landing instructions well in advance of arrival. In circling a field preparatory to landing, aircraft normally travel in a counterclockwise direction. Relatively few airports in the United States require aircraft to circle in the opposite or clockwise direction. Pilots are advised of such exceptions, however, by the control tower prior to their arrival at the field. At some airports, during instrument flight with a low ceiling, air traffic is sufficiently heavy to require a landing sequence. Each airplane is then directed to land when its turn in the order of landing has been reached. Similarly directed, each minute detail of air navigation can be controlled for the safety and expedience of air travel. Army flyers are expected to cooperate fully with the Civil Aeronautics Administration. To promote efficient control, all pilots engaged in airways flying must abide by air traffic regulations. It is also important that they cooperate fully with the personnel directing activities at the ground station.